Hello friends, welcome back to Pure School. Uh, if you're new to the channel, I'd recommend that you subscribe to follow more content and as well to support me. I'll be so grateful. Thank you so much for those who have already subscribed to the channel and always following the content. I'm always grateful for what you've done. By doing that, you support me a lot. So today we're going to look at continuing with our first topic, that's Algebra 1, and we're going to go further into solving quadratic equations. Not by factorization like we did in the previous video, but we are going to now go into completing squares. And these are some of the sample questions that we are going to be looking at today. We have this the first number, second, and the third. So we're going to handle those ones in order to cover this. I remind you, please, once again, you may like the video in case you enjoy it. Hit the thumbs up button, and you'll have helped us a lot. So let's start straight away. I'm not waste your time. So this is a solution. Number one is saying that x squared minus 6x minus 5 equals to 0. Before I handle this question, I want to first explain a few concepts that you need to grasp when it comes to completing of squares. Completing of squares comes as a result of some quadratic equations being not possible. Some quadratic equations which are not possible to factorize. So that means actually you have when you can't get any two pairs like we were looking at in under factorization. That by factorization that you need to get two pairs of the factors of the product in order that when you add you get the sum, or when you multiply them you get the product. Such a condition is not possible here. Even if you try with this number, you'll realize that it's impossible. You can't get the factors of 5 that when you maybe change the signs, that you'll add them and get -6 and multiply and get -5 to be totally impossible. So the aim here is to actually create a perfect square on one side. Let's say we have a quadratic equation of this form. Okay, that our aim is to create a perfect square in that we can just get roots on both sides. We are supposed to create something of this form. Let me say p squared equals to q, so that when you get roots on both sides you get actually a definite root. When you get the roots on both sides, you remain with just making x a subject, and that this one q and p are actually real numbers that whereby you can get the root of q. So but I'm not saying this is now the one for that equation. No, I'm just giving you an example. So we need to manipulate this to be in this form, of which the first steps that would be involved will be trying to separate that constant to the other side, of which we can let it be another constant. Let me say k. Okay, since this is a real number, you can also represent it by another real number where k will be -c. So that when we have something like that, we'll basically have to make this side have a perfect square, in that when we, like for this case, remember, if we expand x plus p squared, you'll have to go back there. Okay, and together with bringing q this side before you had got the root. So that's what we will be looking at here. We'll be trying to create one side to have a perfect square, of which for this case I have some few tips I'm going to give you in order to handle that. And you need to know that there are two conditions. There are conditions when the coefficient of this x squared term is actually 1, and when it's not 1, like for this case. So I'll also give you what to do when it comes to that. Sorry. So I'm going to give you something, and I'm going to solve it, and I just let you realize certain things, certain steps I've taken. To create this, I told you the first step will be to take 5 to the other side. I've separated the constant term from the variables. Okay, so that from here I am going to create now a perfect square from this, whereby I'm going to say x squared minus 6x. Okay, and I'm going to add -3 and square it. Okay, and again subtract it away. equals to 5. When you observe this, I've not done any change here, because negative 3 squared minus negative 3 squared will still be 0. It's like I've not done anything to the equation. So what we are going to remain, we're going to remain with x squared minus 6x, okay? Then here I'm going to remain with what? 9 plus 9 equals to 5. If I take this to the other side, I'm going to have 5 plus 9, which will actually be 14. Let me rewrite it, don't be confused. 6x plus 9 equals to 14. This is how far I've come. You realize that I've manipulated this side here to have a perfect square, because this one here is just simply x minus 3 squared. X minus 3, if you try to expand that, x minus 3 squared, you realize you have squared here, minus 6x, then plus 9. When you expand, you're going to come back to this, so that the whole of this can just be written as that equals to 14. What will we have next? Now we reach that step of getting roots on both sides, so that you have x minus 3 will be equal to, if you get the square root of this, plus or minus root of 14. Why plus or minus root of 14? Because if you square positive root of 14, you'll end up with 14. If you also square negative root of 14, you'll still end up with 14. That's why we are considering both plus and minus. We are not sure. Then what will happen now, if you make x a subject, you're going to have your x equals to 3 plus or minus root of 14. This will be your solution. It's always better to live in this form, because we are looking at exactness when it comes to this. Rather than when you express in decimal places, you'll try to express it as a decimal, you'll end up with a number which is not exact. So now let's go back to the steps and try to see how what we did. If you realize this step, to create that perfect square, actually from this step, I just have I got half of this negative 6 and squared, then subtracted that result away, so that it acted as if I didn't change anything. So you're going to have the coefficient of x together with the sign in front of it. If it was a plus, you'd consider having plus 3 squared here, then minus plus 3. Okay, and from there it's obvious. You take one, the other side, the one is subtracted to cause no change, you take it the other side, this one here. Okay, I did that, so that 9 plus 5, this side became 14. This one remained to give a perfect square. How did I realize that now this one is a perfect square of x minus 3? Because I know it's kind of hard to search that. What you do, just take this negative sign, just take this x, this square terms, see them, take the x and take the minus 3 together with a sign. If it was plus here would be plus, and you take together with a sign. So we have, that's how I determine it, x minus 3, then I just squared. I just given you the tips on how to get it easily without any struggle. So that's all we can do for that number. Let's go to the next one. This one I'm going to be a bit more fast. I'm going to be faster. Let's try to see the next number that we had. Let's go back there. It was x, this one here. It was x squared minus 3x minus 5. Let's come back here. X squared minus 3x minus 5 equals to 0. So what do we do for this case? We realize that still the coefficient of x is 1. You need to realize that when completing squares, the x squared coefficient must always be 1. If not, you have to divide throughout to make it 1. So here, the first step I told you is to take 5 the other side, the constant term, separate it from the variables. Then here we write that, copy that. Then we have a negative 3. Half of negative 3 is going to be negative 3 out of 2. You add the half of a coefficient of x, then subtract it away. Half, when it's squared like that, you square half of the coefficient of x, add it, then you subtract that same value, equals to 5. Okay, what do we have this time? We're going to, when you take this the other side, we're going to have 9. I think 9 minus 9 out of 4 here, when we square this side, we're going to remain with x squared minus 3x. Okay, Then here plus negative 3 out of 2 squared equals to 5 plus 9 out of 14. That's if you take this one the other side. So let's see here, 5 plus 9 out of 14, or 4 I mean, what will be, the LCM is 4. So here remain 20 plus 9, which is 29 out of 4. So we remain here with x squared minus 3x plus negative 3 out of 2 squared equals to 29 out of 4. Okay, that's what we have. So what will we have? I told you that the technique that I use here, I just get this x, then that squared remaining together with a sign, then I square, I equal to that. Okay, that's what I do. That's what I realized, that if you do it, it actually ends up okay. So if you see this part here, if this one here, I mean here, if you try to square this, you'll end up with 9 out of 4, right? So we have actually x squared minus 3x plus 9 out of 4. This is a perfect square. If you expand this x minus 3 out of 2 into x minus 3 out of 2, sorry, you want to sing that? This one here, I mean, let me repeat, you have here that this from this step here, when you square this, you end up with that. I want to prove to you that when I square this, I have to go back to that, which is this. So we have here x squared, x times x, then minus 3 out of 2 x minus 3 out of 2x. Okay, that's what we have. Then we have here negative 3 out of 2 times negative 3 out of 2, which will become a plus of that. So we have here x squared, then here minus 3 out of 2 minus 3 out of 2 will actually be minus 3x. Why? Because we have same, so we just minus 3 is minus 6. Okay, then divided by 2, which will become negative 3, and there's x as well there, then plus 9 out of 4. You realize that we will go back there, which is actually this step. Okay, okay, for this side of the left hand side of that step. So that's it. We go back to our final thing, which is actually that plus or minus root of 29 out of 4. Okay, then we can know that is going to be what do I do? Let me try to split that a bit. X will become 3 out of 2 plus or minus 29 out of 4 under root. So there you can realize that yeah, that's how you get. I hope you've grasped it properly, the concept of completing squares. Let's see now another example here, which was having a coefficient not equal to 1, which is coefficient of 3. Let me take you to another page. I have it was the number is actually 3x squared. Let's focus here. 3x squared plus 4x minus 5 equals to 0. Okay, so that is actually the number. It was our number 3. Yeah. So I told you if the coefficient of x squared is not 1, you need to make it to be 1. So here when we divide throughout by 3, we're going to have that. They have made the coefficient of x squared to be 1. Then we take the constant term the other side, x squared plus 4 out of 3x equals to 5 out of 3. Okay, is that cool? So now we have x squared plus 4 out of 3x. Half of the coefficient of this is actually going to be 2. Half of this is going to be 2 out of 3. So it's going to be plus 2 out of 3. With its sign, it's positive, so we wouldn't bother squared. Then subtract it away. Equals to 5 out of 3. Okay? Half of this, half of 4 out of 3 is actually 2 out of 3. That's why I squared 2 out of 3. Half of the coefficient of x squared minus it again squared minus equals to 5 out of 3. That's what we have. Then I apply, I say x squared plus 4 out of 3x, okay, plus 2 out of 3 squared equals to 5 out of 3 plus 4 out of 9. Okay, let's deal with that one. Let's try to get the LCM there. 9 is the LCM. So we have here 3, then 15 plus 4 is 19 out of 9. Okay, so we have here, we're going to come back to x squared plus 4 out of 3x plus 2 out of 3 squared equals to 19 out of 9. Are we okay there? So we are going to have now x, take this, then that together with the sine, square it. Okay, what do we have? 19 out of 9. Then we're going to remain x plus 2 out of 3 plus or minus 19 out of 9. Remain with x equals to minus 2 out of 3 plus or minus root, sorry, that was root here because I took root on both sides. Okay, the root of 19 out of 9. There you can simplify further. I'm not going to go so far. So that would be the solution, how to solve. When you press on your calculator, you can have an exact, now I think it's not exact in decimal places, but at least you can get two answers from here. But there are some cases. Let me first give you a note. Here are some cases. Some cases you'll not have to go up to solving for x like we did here. Let me say you have your quadratic equation ax squared plus bx plus c, y equals to that. Okay, sometimes you'll just have to leave it in form of a perfect square, and it can be realized. Actually, for this case, you know that coefficients of x squared, x, and the constant term, they are all known. And how do we know that is going to be expressed in a, let me show you how you can express it in a constant term, actually in how you can express it to have in the form of a perfect square. In case you were to complete squares of this, which form would it take? If you complete this, the square of this side here, you'll end up with something like a into x plus p squared plus q. Y, I can take it through the steps. Let's try to say that y equals to, okay, let's say y out of a, y, because I'm trying to make x the coefficient of x1, x squared plus b out of ax plus c out of a. Why? Because I'm trying to why have I divided throughout by a? I'm making this to be a coefficient of x. If I divide by a, I also divide the side by a, so that when I cross multiply, it acts as if I've done nothing to that. I've done nothing. So that now we are going to have should we flip it the other way around so that we be a bit more familiar with? Equals to y out of a. Okay, so now we are going to have x squared plus b out of ax equals to y out of a minus c out of a. What I've done, I took the constant term the other side, so that's a simple thing that I've done. I've taken the constant term the other side, and we're just going to realize that we remain with the variables this side. So what do? We are going to try to make this side a perfect square. X squared plus b out of ax, then we have the coefficient of x, which will be actually plus b out of 2a, we square it, then remove it away so that it appears like we have not caused anything to the equation, equals to y out of a minus c out of a. What will remain here, we realize that we have come back to the other step of having a perfect square on one side. If we take this one the other side, we're going to remain with x squared plus b out of a x plus b out of 2a squared equals to y out of a minus c out of a, then plus b out of 2a squared. Okay, so here we're going to just say that we have a perfect square this side. Remember I told you how to get it already in the previous examples. We're going to take that. Okay, then we got this side. Since we have only values which are known, even y is a real number, a is a real number, c is a real number, we can just let it be a constant term. Okay, we let it be a constant term. And by the way, here there was a is throughout, if you realize here, so you could literally factorize out 1 out of a from here. So we could actually remain with y minus c plus b out of 2a and 1 out of a. Okay, so what will happen here, we're going to just multiply throughout by a. We're going to have a into x plus b out of 2a squared equals to y minus c plus b out of 2a. Since these are all real numbers, I can just represent it by another real number. Let me say the result of this will lead to a real number, say q. No, let me say k. Okay, I'm representing all of this with another real number k, so that we are remaining with actually a into x plus. Now b out of 2a, let's give it another result, a result of dividing b with 2 out of a, with 2a. Let it be another real number. Let me say p, since these are all known real numbers, so their results would as well be real numbers. Then that k, if we bring it this side, would be a minus k. Let it be another real number. Let's take pq, so that we just have a positive q this side. That would go back the other side. Actually, we could even leave y here. We could leave y separate, so that we go back to the other equation that we looked at before. There, this was also y, because this was the form. This form was actually a solution, a simplified perfect square. Its form is actually, when you complete square of this, you will have its form of this, which is what we have just come out with here. Let's assume that here we had removed y from our assumption, that is equal to k, only this one being k minus of that, so that we remain with that. So that when you remain with y that side, you bring this side k, actually k, which is minus b out of 2a minus c, to be your q this side. So that's how it would be. We would actually have now a into x plus b squared plus q being y, which is actually this form. When we complete it square, we go back there. That's how you come about it. So I would like us to look at some example to see how you could refer that, but I will not do that right now. I'll just show you how you will have to compare. Say we have a y equals to that squared bx plus c, and it's when we completed it square, we had y equals to a into x plus p squared plus q. Since they're the same, you just compare them. You expand this, if we expand this, we're going to have, let's deal with this. Okay, we have y will be a into x squared plus 2px, then plus p squared. If we expand this, then plus q. What will we remain with? Remain with y equals to ax squared plus 2apx plus ap squared plus q. Okay, so since now all we have three. We have coefficient of x squared, we have coefficient of x, and we have coefficient and we have the constant term. Okay, so you compare ax squared plus 2ap x plus ap squared plus q, constant term, coefficient of x and coefficient of x squared, with the original one, which is ax squared plus bx plus c. You compare them, you get their value. A is known already, a will always be known. A, b and c are all known, since they were the original form of the quadratic equation. Okay, and actually then since you have b here, a is known, you can also solve for p. If you compare, you start by comparing coefficient of x squared Okay, x squared first, you go to x, then the constant. Okay, by doing that you'll get all the you'll be able to solve for p and q, which are the only unknowns in the equation. You can get p and q can actually be solved. Okay, I want to say thank you so much for coming to the channel. I'm so grateful by your presence, and if you're new to the channel, please don't forget to subscribe, and in case you enjoyed the video, don't forget to like. Stay tuned for our next video.